So hello everyone. Unfortunately, I could not join you in person this year, but anyway, it's good that we can speak online. My name is Denis. I'm a head of developer relations at Yugabyte, and today we are going to talk about cloud storms or cloud outages that are inevitable, that are happening all the times, and what can we do about that by applying modern data management patterns for reliability and availability. So let's first talk about the storms, possible storms in the cloud or outages. If you go cloud native, if you already use cloud environments or planning to do so, if you deploy your data layer on VMs or using Kubernetes, you have to be aware of these situations. If you follow AWS post-event summaries, you will find that outages happen all the times. Zone level outages are commonplace. Sometimes the server can count down or like network can be broken between several availability zones, but even region level outages are becoming the new normal. If again to follow the AWS post-event summaries report alone, you will see that starting 2011, AWS alone had a major outage at least once a year. And if you try to dig deeper, you will discover that on average, it took 4+ hours to restore an impacted area. What does it mean to you? Like, there is some stuff that is not under control. Also, I refer to this stuff as what are the problems? What causes those major cloud outages? It can be, let's say, a banal hardware or networking related failure, because you know that cloud environments provide vast and enormous resources, and all that complexity is inevitable that breaks all the times. At the same time, also nobody builds perfect software. Let it be, let's say, like a web application, mobile application, or any services developed by Google Cloud Platform or Microsoft Azure engineers. So bugs and outages in the cloud service can impact your environments as well. If to give you an example, Amazon Kinesis outage that happened, let's say, several years ago, cascaded and impacted many dependent services. People who have never used Amazon Kinesis directly were impacted as well, because Kinesis is used by other public services provided by Amazon. And another issue, like, we are humans, we do mistakes, and that's okay. It's okay to fail, but then we just need to recover. If some of you remember one of the most notorious S3 outages that happened in our history, that outage was caused by a simple dummy mistake. An AWS engineer executed a command and he messed up with some arguments, parameters, and that cascaded, let's say, to failures across a big chunk of the AWS infrastructure. But there is some stuff that is under your control. Remember, those are outages that happen all the times, even region level outages, and you need to do something about that, because you run your data layer powered by Kubernetes. You run your applications also in Kubernetes in the cloud, and you need to do something. So what should you do? First, accept the fact that cloud storm or cloud outages can happen to you. It can happen sooner or later, right? And its impact depends on like what exactly went wrong in the cloud. And when you're building new applications, so when you're designing and architecting new solutions, design multi-zone or multi-region deployments. I also frequently being asked this question, like, if I want to care about high availability and reliability in the cloud, should I deploy my solutions and architect for multiple cloud vendors? I usually refer to this post by one of the Gartner analysts, Lydia Leon. She said that, no, I mean, guys, if you want to use multi-cloud just for high availability and reliability, then don't do this, because every cloud vendor has multiple regions, right? And you can take advantage of those regions to survive all sort of different outages. And what's about speed and scale? Because on the next slide, I will be talking about, I will briefly talk about those patterns for data reliability and high availability in Kubernetes. But what's about speed and latency, especially if I'm encouraging you to deploy your data layer across several zones and regions. Let's say, talk about Google Cloud Platform, the latency between multiple availability zones that belong to the same region are extremely low. It's just like 5 milliseconds. I mean, it's almost nothing, unless you are building different trading platforms where you need to kind of sustain sub-millisecond or nanosecond latencies. Also, when it comes to regions, multi-region deployments, we are going to discover several different patterns that will maximize your speed and also will make you reliable. But with regions, you need to do some work. It depends like what regions you select. For instance, if you deploy your data layer or your applications in US West, Oregon, and you want to have let's say a highly available solution, you probably can use US East North Virginia because the latency time is 60 milliseconds. However, if you decide to span like that data layer across US West and London, the latency is 2 times more. If you want to have a secondary, let's say, data layer in Mumbai, the latency is getting even worsens as well. However, if you want still to have, let's say, something in the United States, and you want to have that multi-region deployment across the United States and Tokyo, then like you see that how it compares to Mumbai. With Mumbai, it's 220 milliseconds. But if you just select another region, in, let's say in Tokyo, and serve your Asian customers from there, the latency will be much better. All right, let's briefly talk about those data management patterns for reliability and availability. So here is again, let's say that you're selected Kubernetes to deploy your data layer, and let's talk about databases. It can be data store, it can be cache, it can be some in-memory database or disk-based database. So the first one, obvious thing is that you have some primary database instance in one of your geography. In my case, I selected United States because I live here. And here is what's important, that primary database can span multiple zones or local regions. And it's important because inside of that geography in the United States, if I deploy within one zone, everything can fail, right? Remember those reports, zones fail frequently. If I deploy across multiple availability zones, it's great, right? At least if one zone goes down, the other will serve my user requests. Or also you can deploy across multiple local regions. Under the local region, I mean, let's say I'm deploying something in the US East Coast, and also that database is scattered across the US East Coast and US South region. If, let's say, US South region gets disconnected, my data layer will serve all the requests from the East and vice versa. At the same time, and this pattern, multi-region database deployment with read replica used in when all the reads and writes by default go to the primary cluster. But if you want to serve reads faster to in your remote locations, such as let's say in Europe or Asia, you can deploy read replicas. And with read replicas, data will be asynchronously replicated. We are not going to talk about mechanics because it depends on the database, from a database to a database, but generally it works. Some of the databases also use read replicas as standby kind of database instances. If your primary cluster goes down, then you can switch to the replica. But in this case, I mean, if you suspect that your primary cluster can go down, in your primary region, my advice to you is to deploy each primary cluster across multiple local regions, such as US East and US South, right? Because it's better. Another second pattern here, multi-standalone databases with async replication. And this one, I guess, most of you are familiar with, and most likely you already use it in practice for a while. And it's an all good pattern, and keep using it. So the idea here is that you have multiple standalone databases instances deployed in every desired location whenever you serve your customers. It's Europe, Asia, and America. And if let's say someone lives in Europe, you will serve all their data from the European instance. And every instance, again, is highly available and scalable in every region. Meaning that if you have a cluster database instance in Europe, then that instance can span several local regions, such as in Frankfurt, London, and you pick the other region, if you like. If it's necessary, you can always enable asynchronous replication between those standalone databases, if it's needed, right? Because sometimes it makes sense, sometimes it doesn't. But again, to remind you, within every location, such as America, Europe, all the changes within those regions are replicated synchronously. That's important. And another final pattern that is used by some contemporary databases is geo-partitioned multi-region database deployment. In this case, how is it different from the previous one? You have a single database deployed in Kubernetes across multiple geographies, and your applications, your users get a single connection endpoint, just one. But then the database automatically decides where to place your data and where and from what instance to serve your requests. For instance, if you have a customer connecting from Frankfurt and he wants to read data or write data, then database will automatically route those requests into your European nodes, into the European group of nodes that serve the database. And that database decides this automatically based on the value of so-called partitioning column. In my case, that's the country column. And based on the value of that country column, if the value is set to United Kingdom, or France or Spain or Italy, then all this data request will automatically be routed into those nodes that are based in Europe. Okay. So if you want to learn more, we run out of time. My advice to you is to study Architecting for Scale and Designing Data-Intensive Applications books by O'Reilly. Excellent start. If you want to dive deeper into this topic of multi-region and database deployments and data availability patterns in Kubernetes, then you can check my detailed blog post on DZone. So you'll find references on these slides. If you have any questions, you can follow me on Twitter, Denis Magda, and also you can join our Slack community where I am not a stranger. So thanks for joining and hope you learned something new today from me.